guaranteed that we get it. Very, very important. Sound and complete with regard to all the transaction isolation use cases. All right, moving forward. How to please everyone. We have some features. Store by reference is a feature that we allow. Okay, you know, in the typical map, it's a store by value. Store by reference, you get much better speed. XA and local transactions are an optional feature. Caching interception, that's also optional. We have a capabilities API, so you can consume what options are provided by the provider. Okay, so we have these two classes give you helper methods, and you can say whether or not the feature is supported in the provider. Okay, standalone versus distributed. If you're a standalone in a single VM, we can give you store by reference, the store by reference option, which gives you speeds similar to current hash map. Cache event listeners are very useful for triggering events in a standalone environment. If you're in a distributed environment, we're going to give you store by value, because a reference in a distributed, in a distributed setting, a reference loses its meaning really. We short circuit some things that you would expect to see in a map API, like there's no values method, and the remove method doesn't return the object, it just returns a Boolean, some things like that. There's no need to have much detail. So we short circuit some of the things you expect to see in a map. JSR107 is not a grid specification. JBoss's InfiniSpan, Oracle Coherence, and IBM's ExtremeScale, those are all data grids. EHCache and Memcache are distributed client-server caches. Manique Sertani, who heads the JSR347 specification, he's also a very strong contributor to JSR107. The difference between 347 and 107 is that we don't mandate a topology. There's no in-place specification for the topology of your solution. JSR347 does specify that. Class loading. Class loading is very tricky when you get with caching solutions. If I have a JBoss application server and I have A.war and B.war, and each of those wars contain an employee.class, and the employee.class is bytecode for bytecode identical. If A.war, if its class loader loads employee.class into the cache, okay, and then mutates it, and then B.war, its class loader loads employee.class for the purposes of reading from the class. Does anybody know what will happen? Yeah, class cast exception, exactly. This means that, and it's because even though employee.class and employee.class are bytecode equivalent, they're not the same, because A.war has a class loader and B.war has a class loader. So we solved that problem by specifying, when you create a cache manager, okay, you have to specify a cache manager's class loader, okay? That prevents that problem of employee cannot cache to employee, which drives people bonkers. What else? Okay, we support two ways of creating a cache manager. We have the service loader creation, which is part of Java 6, and we also have, the new constructor, which is familiar with everyone. One of the important things to notice is that when you're loading a cache manager, you want to include the notion of the cache manager's class loader. Okay, that's important. Okay, how do you create a cache? Well, you have to really go to the API to see this fluently. But we use what's called the fluent builder pattern. So as you do set certain parts of the cache, we return a reference to that cache manager. So you can just everyone knows the fluent builder pattern from Joshua Bloch's book. Very powerful way. We adopt that for building cache managers and for specifying what features are set in your cache manager. Yeah. Yeah. Okay, just a couple more. We have a method called unwrap. This is a way to get to the underlying provider's proprietary API. We were going to call this method lock yourself back into proprietary caching code, but we decided we'd just call it unwrap. Okay. Annotations. I guess we could just skip the annotations part. Just know this, we have a rich way of specifying annotations. It allows you to give cache consequences to code that already exists without having to write caching code, if that makes sense. You know what I mean? Okay. More information on this. Everything is available on GitHub. Everything is completely open. If you want to pull down our API artifacts into your build environment, we have an artifact registered in Maven Central. We're on the 0.6 version. Okay. Let's see. That's the end of it basically. I want to acknowledge Greg Luck and Cameron Purdy. Much of this PowerPoint was taken from their Java 1 2011 presentation. I want to give them credit for that. Okay, so that's it.